Hi friends, welcome to Rishi Learns Tech. Today I would like to discuss with you about what is the importance of calculus in machine learning. So today we will be covering about the most important concepts of the calculus, how it is applied in a machine learning project or while building the machine learning model, and we will be also discussing about the uh, one algorithm which is the most basic algorithm that we have to understand for increasing some kind of uh, accuracy or performance of the model. So let's go on to the video. I would like to also mention that I am also sharing blogs in the medium about all these topics which I am studying right now. So I will be providing the link of that medium blog in the description below, so kindly check it out and please do read those things, because reading will also make you more get a more clarity on what we are talking about. So just after we watching this video, kindly check out that medium blog also. So talking about the calculus, we have heard about integration, differentiation, limits and derivatives. So all these things while we are studying in our schools, right? So at that time we will be thinking about where these things are used, how these are going to make changes in our life, right? So in this world now, the ruling thing is the artificial intelligence or the machine learning models or the agents which are automated. So all these things are actually implemented using the topics or the concepts uh, which is coming in the calculus. So we will talk about it. So what is calculus? The calculus is actually acting as a mathematical framework, so which will help us to understand how the machines are learning or how the machines are optimizing their performance. So it also helps us to understand how the small change in the input will cause or impact on the output, how a small change in the input will impact on the output. So this is the basic concept. So whenever a machine learning model is building or in the training stage, what they are doing is the model is actually finding the mathematical patterns or the relationship between the data which is given to the model for studying, and then that model is actually finding out some particular patterns or some ideas to predict the output. So this is how learning is happening. And in case of optimization, when optimization means making the prediction more accurate. So for this thing we are actually using the calculus differentiation concept. So differentiation is actually finding the slope. So when we plot the how the model is performing on a graph, it will be like it will have a slope. So if that slope is high means it will be there will be more chance of error, or the error of that particular model will be high. So we will try to decrease the slope, so that what happens, so that the errors in the model will become less and the model will become more accurate and more precise. So that is why we are saying this calculus is coming majorly in the concept of optimization process. So after building a model, we will be tuning the hyperparameters, or we will be adjusting the parameters of this model to make its prediction more accurate or more closest to the actual value that we need to find out from the that we need to predict. So this optimization process is the process of reducing the errors or reducing the loss function or cost function. This loss function and cost function are actually the measure of errors with respect to the data point or with respect to the data set in the machine learning concept. So we will be reducing this loss function and cost function, so that we will be getting more precise, or uh, we will be getting the model with more precision and more performance. So in calculus we are studying about limits. So limits is actually the it is the calculation of the value that we are approaching to. Means while we are predicting, we will be calculating a value. That that value is actually the limit, and it need to be continuous. So if there is any breaks in between, if we plot a graph on that, it should not, it cannot be considered as a smooth one. So for making it smooth, that graph should be continuous. So what is differentiation? Differentiation is actually a continuous function approaching to a limit. So limit plus this continuity will become the differentiation. So that is the differentiation. So there are many rules in this calculus also, like chain rule is there, product rule, quotient rule. All these are coming under the differentiation part of uh, calculus. So all these rules are also actually doing something in or contributing something to the mission while building, contributing something to build a model. So for example, if you're taking chain rule, this is actually in the backpropagation algorithm. Using feedback, the error is reduced. So this reduction of error is done using the chain rule. It is the application of chain rule. And whenever we are trying to calculate the loss function or the cost function, we are actually finding the multiplication, or we are finding the product of two functions. So at that time the product rule is applied. And whenever we are finding the probabilities or the ratio of the probabilities while doing the normalization process, what we are doing is we will be dividing, like we will be dividing. So here the quotient rule is applied. So all these kinds of rules are also taking a major part or contributing to the optimization part in a large sense. So differentiation is the main concept that we are using for the optimization process. How means in the differentiation we know that dy dx is the slope of a straight line. So slope means actually the error in that particular thing when coming to machine learning concept. And we will be reducing this error, which means we will be reducing the slope into 0. So whenever the slope is 0, we will have the minimized error or the least error or zero error. So at that time the model's performance will be like very huge, very high. It will be performing very good on whatever we have given for training, as well as we have giving for testing also. This is how differentiation make changes in the optimization or help us to optimize the model to get a better performance. So there is one algorithm called gradient descent algorithm, which is used for the optimization process while we are building the model. So in this algorithm we will be finding the gradient. This gradient is actually the the slope only. So when we are plotting in a 3D plane, this slope is termed as or named as gradient. So that's why in this algorithm it is saying gradient descent algorithm. So gradient descent algorithm means, descent means we will be reducing, we will be coming to downward. So whenever it is coming downward means we will be changing the slope into reducing the slope to get 0. So in this algorithm we will be finding the global minima or the local minima, so that the error will be very less and we will get maximum output of that model, so that it will perform well and we will get accurate values for the newly given testing data set. The differentiation topic is actually done for some problems having single variable as input, but when it comes to the partial derivation, this partial derivation is actually an extended version of differentiation where we will be using multiple variables. So it will help us to perform multi-variable optimization. So differentiation is for single variable optimization, and partial derivative can be used for multi-variable optimization. So actually, this gradient descent algorithm, we can say like it is a process of optimization that we are doing to calculate the minimum error, or to get the reduced cost function by adjusting the model parameters in the opposite direction of the gradient, so that we will get a high performance output from the model. So if you're thinking to try all these kind of differentiation, partial differentiation, integration, and limits and derivatives, all these things in Python from scratch, means you can use one library called SymPy, in which we can do perform some manipulations using the algebraic variables. Also inbuilt functions for differentiation, integration, and partial derivation, all these things are in that library only. So kindly refer to that SymPy library and go through that for getting a better understanding about all these concepts, like how the all these calculus concepts are implemented using Python with the help of SymPy library. So as of now, I have spoke about what all are the different concepts in the calculus, as well as how these calculus is affecting the machine learning models, and how we are optimizing using this gradient descent algorithm. So I hope you will be clear about all these concepts. So thank you for watching until this much time. Please do subscribe for more videos like this. Actually, I am studying this machine learning from the scratch, so you will be also getting an idea of how to start a project and how to study all these concepts. So check out my other videos as well. I am also writing the blogs in the Medium, so kindly check out. I will be providing whatever links is there in the description. So until we see in the next video, thank you for watching. Bye.